Welcome to Engineers Career Group online crash course. My name is Brijesh Temla and today I will discuss some important topics for the basic thermodynamics which is useful for GATE as well as engineering services exam. In the GATE examination, the thermodynamics subject found 11.3 average marks since last 10 years. For the thermodynamics, the important topics, or we can first we can discuss the syllabus related to basic thermodynamics. First of all, we start with the introduction. In the introduction part, we study some basic terms like what is system, what is surroundings, what is boundary, what is universe. Then various types of systems are there, like open system is there, closed system, isolated system. Then there are two types of approach we use to study the thermodynamics. One is the microscopic approach and another one is the macroscopic approach. After that, we study about the properties of the system. The property means the measurable characteristics of the system like pressure, temperature, volume, density, thermal conductivity and so on. And there are two types of properties. Intensive properties are there and extensive properties. Intensive properties are independent of size and mass of the system, and extensive properties does not depend upon the size and mass of the system. Intensive properties is for pressure, temperature, mass density, thermal conductivity, and extensive properties is for like volume, mass itself, all forms of energy. Specific your enthalpy is there, kinetic energy is there, potential energy is there, entropy is there. So all these are the properties, or you can say extensive properties. These are and they depends upon the mass of the system. And after that we study some important points with respect to properties, like they are point functions that does not depend upon the path followed by the system, and they are exact differential. So these are very important points for the properties. After that, we study what is state. Change of the state is called process. Number of processes are there. Two types of generally processes are there: reversible process and irreversible process. Reversible process is used for the comparison purpose, and under actual condition the processes जितने भी हो रहे हैं because of the friction is involved is there. That is why वो जो processes होंगे, these are called irreversible process. And then in very basic, in introduction, we study Gibbs space rule. According to Gibbs space rule, P plus F is equal to C plus 2. This one is for the Gibbs space rule. P here is for the number of phases, C is for number of components, and F is for the degree of freedom or minimum number of intensive properties required to fix the state of the system. So by using the Gibbs space rule, we find out the degree of freedom of the system. Then in thermodynamics, we study three types of law: zeroth law, first law, and second law. First of all, we study the zeroth law of thermodynamics. The zeroth law of thermodynamics actually gives us the concept of the temperature, and after zeroth law of thermodynamics we study the thermometric principle. In thermometric, actually this thermometric principle is used to find out the temperature of the system, and After thermometric principle, we study the various types of thermometers, like resistance thermometer is there, thermocouple is there, gas thermometer, ideal gas thermometer, constant volume gas thermometer, constant pressure gas thermometer is there. So various types of thermometer we study in only introduction, or you can say under the 0th law of thermodynamics topic. After 0th law of thermodynamics, we study about the energy transfer involved in thermodynamics, that is heat and work. In thermodynamics, the energy transfer takes place via two methods. It takes place via heat or via work. So we study what is heat, what is work. Various types of works are there, like shaft work, electric work. तो सभी work जो हैं वो इस topic में cover होंगे. And heat we know that it is the energy interaction because of the temperature difference. After heat and work, we study first law of thermodynamics. The first law of thermodynamics is actually based upon the conservation of energy. Conservation of energy means energy is conserved. And according to first law of thermodynamics, if a closed system is undergoing a thermodynamic cycle, then net heat transfer d dash q is equal to net work transfer, that is d dash w. This is the net heat transfer and this is the net work transfer for the thermodynamic cycle undergone by the closed system. So this is the first law of thermodynamics, you can say, equation for the closed system. And further, this equation can be simplified to, can be modified to d dash q is equal to dE plus d dash w. So this equation was valid for the cycle and this is further simplified for the process. So when a closed system undergoes a process, d dash q, that is the heat transfer, is equal to change in energy dE plus d dash w. D dash w is for the work transfer. Means heat transfer is equal to change in energy plus work transfer. So this equation is valid for any process, चाहे वो process reversible है, चाहे वो irreversible है, but the system is closed system. Now if the process is reversible, for the reversible process undergone by the closed system, d dash w is equal to p dV. P is the pressure and dV is the change in volume. And further, if change in, when the process occurs, when the change of the system takes place, when the change of the state of the system takes place, the change in kinetic energy and potential energy, if it is assumed, is neglected. I am assuming the change in kinetic energy and potential energy is negligible. Then the change in energy of the system is equal to change in internal energy. So this equation d dash q is equal to dE plus d dash w reduces to d dash q is equal to du plus p dV. So this is the first law of thermodynamics equation for the closed system, and this is valid only for the reversible process and when change in kinetic energy and potential energy is neglected, because d dash w is equal to p dV is valid only for the reversible process. D is equal to du, u is for the internal energy, is valid only when the change in kinetic energy and potential energy is neglected. So this is the first law of thermodynamics equation for the closed system. Now the first law of thermodynamics equation for the open system. That is for the steady flow energy equation. Steady flow energy equation. We know open system is that system in which no mass transfer involved, only energy transfer involved. And if the flow is steady for the open system, steady flow means the mass entering the system is equal to mass leaving the system. Energy entering the system is equal to energy leaving the system. Or you can say the properties of the system or properties of the fluid is not varying with respect to time at any particular location, at a particular section, then such type of flow is called steady flow. So only assumption for the steady flow energy equation is that the flow is steady flow, and the steady flow energy equation is actually H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus WCV. Here H is the specific enthalpy. This is kinetic energy per unit mass. This is potential energy per unit mass. Q is the heat transfer. If it is absorbed by the system, then it is taken as positive. If it is rejected by the system, then it is taken as negative. And here WCV is for work input or work output. Work input means work is done on the system, it is taken as negative. And WCV is for, it can be for W output, means when the work is generated by the system, like by the turbine, then it is taken as positive, that is work done by the system. Means जो WCV है, that is for input and output. Input is for negative, work is done on the system. Output is for the positive, work is done by the system. So this is actually the first law of thermodynamics equation for the open system. After first law of thermodynamics, we study next topic, that is second law of thermodynamics. The second law of thermodynamics is also called directional law. Actually, the first law of thermodynamics tells us when the process occurs, the energy is conserved, but it does not tell us in which direction the energy is flowing. It is flowing from state 1 to state 2 or state 2 to state 1, and this flow of energy was given by the second law of thermodynamics with the help of a concept called entropy. So entropy concept was given by the second law of thermodynamics, और entropy concept की help से ही जो second law of thermodynamics है, ये हमें बताता है कि किस direction में energy का flow हो रहा है. It is flowing from, energy is flowing from section 1 to section 2 or section 2 to section 1. And after second law of thermodynamics, the concept comes of availability, available energy, and irreversibility. But before that, second law of thermodynamics also gives us the concept of heat pump, refrigerator, and heat engine. Or we can say there are two statements for the second law of thermodynamics. The first statement for the second law of thermodynamics is Clausius statement, and the second equation for the second law of thermodynamics is Kelvin-Planck statement. Kelvin-Planck statement, जो Kelvin-Planck statement है, it gives us the concept of PMM2, that is perpetual motion machine of second kind. And according to Kelvin-Planck statement, it is impossible to construct a device which can exchange heat energy only with one reservoir. It is impossible to construct such type of a device. Like suppose there is a device, this one is the source. Source means it is the thermal reservoir, thermal energy reservoir which supplies the heat energy without undergoing any temperature change. Now this source, whose temperature is T, supplying the Q amount of heat energy, and the heat energy supplied to this device is completely converted into work output. According to second law of thermodynamics, according to Kelvin-Planck's statement of second law of thermodynamics, it is impossible to construct this type of device, and this type of device is called PMM2, that is perpetual motion machine of second kind. And in this, Q is equal to W. We know जो efficiency होती है, that is work output upon heat input, and in this Q is equal to W. So Q upon Q, that is equal to 1 or 100%. So the efficiency of the perpetual motion machine of second kind is 100%, and PMM2 is impossible, so efficiency of any device, of any engine, 100% is also impossible. Okay, then there is second statement for the second law of thermodynamics, that is Clausius statement. According to Clausius statement, heat energy cannot flow from low temperature body to high temperature body on its own. It is actually a non-spontaneous process. Spontaneously, heat energy flows from high temperature body to low temperature body. If we want to make the flow of heat energy from low temperature body to high temperature body, for that work input has to be given. Like refrigerator is a device which maintains the temperature of the system lower as comparative to the temperature of surroundings. So जो refrigerator है, ये low temperature body मतलब refrigerated space में से heat energy absorb करेगा and higher temperature surroundings को reject कर देगा. So here the heat energy is flowing from low temperature system, low temperature refrigerated space to high temperature surroundings. इसके लिए work input has to be given. अगर वर्क इनपुट ना दिया तो it is impossible. It is impossible to maintain the temperature of refrigerated space lower continuously as comparative to the temperature of surroundings. So simple, this was Clausius statement. So Kelvin-Planck statement gives us the concept of the heat engine, and Clausius statement gives us the concept of the refrigerator and the heat pump. Refrigerator बता दिया, and heat pump जो है, it maintains the temperature of the system higher as comparative to the temperature of surroundings. Then in second law of thermodynamics, there is a term that is called Clausius inequality. Clausius inequality actually tells us the nature of the cycle. The cycle is whether it is reversible, irreversible, or it is impossible. For a cycle, for a thermodynamic cycle, we will check out the closed line cyclic integral of d dash q by t tau. It can be lesser than 0 or it can be equal to 0. It can be lesser than 0 or it can be equal to 0. If this quantity integral d dash q by t is lesser than 0, then such type of cycle is called irreversible cycle. And if this quantity integral is equal to 0, then such type of cycle is called reversible cycle. And if the cyclic integral of d dash q by t is greater than 0, then according to second law of thermodynamics, such type of cycle is impossible. ऐसा कोई cycle हो ही नहीं सकता जिसके लिए d dash q by t का cyclic integral is greater than 0. The next topic after the second law of thermodynamics is entropy. Entropy we know, indicated by S, and it is actually the measure of the degree of randomness of the molecules. More the degree of randomness of the molecules, more is the entropy of the system. And it is a property, and when the state of the system changes, entropy change is given by greater than or equal to d dash q by t. If the process is reversible process, then ds is equal to d dash q by t. D dash q is the heat transfer. It can be positive or it can be negative, and T is the average temperature at which the heat transfer is taking place, and ds is greater than d dash q by t. This one is for the irreversible process. This is for irreversible process, and this one is for the reversible process. So overall we can say ds is greater than or equal to d dash q by t. And in the entropy concept, we will find out entropy change. In this topic we will find out the entropy change for the ideal gas and entropy change for the solids and liquids. Then next is available energy, availability, and irreversibility. So available energy means, available energy is actually the maximum amount of work which we can get from a given cycle. Availability is the maximum work we can get from the process, and irreversibility is actually the cause of work lost. This arises because of friction or because of the finite temperature difference in between the two bodies where heat transfer is taking place. So irreversibility is actually the maximum work minus actual work, because actual work always reduced because of the irreversibility. So irreversibility is equal to your maximum work minus actual work. For a given cycle, the maximum work is available energy, and for the process the maximum work is availability. After that, the last topic for the basic thermodynamics, that is properties of pure substance. So pure substance means which is homogeneous in chemical composition and homogeneous in chemical aggregation. The very common example of the pure substance and thermodynamics is the mixture of water and the steam. In the properties of pure substances, we find out the properties of the pure substance, like what is the specific volume, what is the specific enthalpy, specific entropy, and specific internal energy of the pure substance, that is water plus steam mixture. Thank you.
Subscribe to us now.